All right, let's continue. Now question 3. The rate of deflection from a horizontal position of a 3-meter diving board when an 80-kilogram person is x meters from its fixed end is given by dy dx equal to negative 0.03 bracket x plus 1 close bracket square plus 0.03, where y is the deflection in meters. Right? So this time we get to work with we get to work with diagrams. How exciting. So that's the diagram over there. So it says that when so this whole diagram, this whole diving board is 3 meter long. So let's just draw something on there. So that is 3 meter long. So it says when an 80-kilogram buff guy standing on it, he's 80 kilogram. It causes that amount of deflection. Right? So he's an x meter from this fixed point. I suppose that is also x meter away from the fixed point. So this is the x. So how far away he is from the fixed point here. Right? So we're given a function. He said, okay, the first question is, what is the deflection when x equal to 0? So literally what they meant is, what happened if the guy stands at the fixed point? Would there be any deflection? I don't think so. He's a standing fixed point. The deflection only happens when you are x meter away from its fixed end, and you are 0 meters away, you're on the fixed end. So there will be no deflection. So that was easy. So question, so since the horizontal, let's call it, let's use technical term, horizontal displacement bracket x is 0, there is no deflection. Hopefully you don't need to use math to determine that. You can just look at the diagram. Alright, so B determines the equation which measures the deflection. Now, remember, the equation we are given is the rate. Let me highlight that. Is the rate of deflection. So that is that. Right, remember, this is the rate of deflection, not the deflection is itself. So the rate of deflection is governed by dy dx. So if that means y would be the let me use a different color. So that means if y is the deflection, x is the horizontal displacement. Right? So what it's literally telling you is the deflection, delta y, so the change of deflection, with respect to the change of horizontal displacement. Now, understanding that, the mathematical expression, understanding that, it tells you the answer of A anyway. So since the deflection is with respect to the horizontal displacement, when there's no horizontal displacement, such as x equal to 0, there's no deflection, right? So after we figured it out, so we can write down the function before. So we got negative 0.03 bracket x plus 1. Okay, so we got dy dx is equal to negative 0.03 x plus 1 square plus 0.03. So we remember the question asks us, determine the equation which measure the deflection. If y is the deflection, so we have to find an equation for y. Well, so far it will be easy, right? Because so far what we've been doing is integrating it. So we know that integrating 1 with y will give us y. Right? Integrating a constant with respect to a variable will give you the variable. So either way, because of what we did here, we have to move the dx to the other side, so we have to integrate this side as well. Of course, with respect to x. Right, straightforward. Now that side literally just become y. Yeah. Now remember, we've got two part over here. We've got negative 0.03 multiplied by x plus 1 all square, and we got positive 0.03 as well. So like I said last time, you can distribute the integration sign into the function or into the numbers, so we get this. So we can do this, right? It makes it easier. It makes you look at things easier. But look, if you are happy to just integrate the whole thing at one go, by all means, go for it. I just want to make sure you guys see it clearly what is actually happening, or what can you see that as? Because sometimes it might help you. So let's integrate it parts by part. All right, so we got a little, similar chain rule here. So we can remember the negative 0.03 is just a constant. We can move it out. So we go x plus 1, right? And now this is a constant integrated with reflecting to a variable, so it becomes that. You just get the variable at the end, yeah? So now we've got in the middle, got the middle part to solve. Now remember, when we derive this, we use the chain rule. The chain rule, which is the power multiplied by the power and power minus 1. When you integrate that, it's completely opposite. So the rule says that when you integrate that, you have to plus 1 to the power divided by the power and multiply by the, to stress this one out, people always forget, multiply by the derivative of the inside, right? So which is 1. That's what's happened at the end. All right, so that would become negative 0.03 close bracket x plus 1 all to the power of 3 over 3 plus 0.03. Right, now at this point you can make this into nice you can factorize it, but I mean you will get this. If you factorize it, you took the common factor out, which is a 0.03. So if you can take the 0.03 out, so whatever left inside the bracket would be a negative x plus 1 3 all over 3 plus this. So when you take negative when you take negative 0.03 out here, what do you get? You only get x left. All right, and then don't forget our plus c at the beginning. So this is the equation of the deflection, but still, like we always happen, we've got a c in there, we've got an unknown in there. So we need to find something to represent, to figure out the c. Right, to find out the c, remember in question A, it asks us what is the deflection when x is equal to 0. And we give that answer, well, the deflection will be 0. All right, so we can actually use that as a coordinate to submit into the equation that we got here to figure out c. So we know that when x is equal to 0, there's no deflection, right? So y equal to 0. So let's sub that in. So it becomes 0 equal to 0.03 negative 0 plus 1 to the power of 3 over 3 plus 0 plus c. Yeah, a lot of zeros around. Alright, so this one becomes 0 equals 0.03. Now negative. Now 0 plus 1 is 1. 1 cubed is still 1. Right? Plus c. So we get that. So 0.03 is just multiplied by negative 1 over 3 plus c. And we get a negative value, right? So 0.03 on top of 3. Right? So this is a negative plus c. So therefore, c would equal to, oh, so when you move to the other side, it becomes a positive. Right? So that would be your c. Now, if you don't like, the decimal on top, you can multiply by a factor of 100 on both sides. So you get 3 over 300. Right? And then you can also change that into, you can change that into 1. So, therefore, 1 over 100 equal to c. Equal to c. And that is same as 0.01 equal to c. So our function is, therefore, the complete function is y equal to 0.03 bracket negative x plus 1 to the cube over 3 pluses x, and then pluses 0.01. So that's our entire deflection equation, right? So I know that when I'm doing so many of this, I know that we will need that to find the answer to the last question, which will be C. Hence, find the maximum deflection. The maximum deflection. So what does it mean by maximum deflection? Remember, our diving board is 3 meters long, right? So the maximum deflection obviously happens if you're standing on the edge of that 3 meters. Remember, the deflection is with respect to the horizontal displacement. So if you're standing on the furthest point, you will get the biggest deflection. So when x equal to 3, let's see what will happen. Find y, which is the deflection, the maximum deflection. So y is equal to 0.03 negative 3 plus 1 to the cube 3 plus 3 plus 0.01. Right, so we get 0.03 4 cube. 4 cube is 4, 4, 16, 64. Negative 64 on 3 plus 3 plus 0.01. Now, to make them into the same, to plus these two together, we have to make them into the same denominator. So we convert this to 9 over 3. Yep, so we get 0.3. Now, negative 64 plus 9 would give us negative 55. Yeah? Over 3 plus 0.01. So our y is equal to 0.03 multiplied by negative 55 over 3 plus 0.01. Alright, let me grab my calculator. So 0.03 times negative 55 divided by 3 would give us y equal to negative 0.55 plus 0.01 would give us y equal negative 0.54. Right? Now, since we use let's look at the so I know you have to put units behind every answer, so I have to look at the actual equation, the actual question. It says 3 meters. So since we use meter in the calculation, this must mean meters as well. So the answer is meter. Now, a negative here, not the people who don't get it. Also, what is a negative? Negative is just a direction, so it's deflected downward instead of upward. Right? If it's upward, we would that call inflected. But anyway, I'm not that good with English. So the negative is just downward, so it would deflect downward 0.54 meter, or you can also say it's equal to 54 centimeter. Alright, I believe that would be the answer in the textbook. So either 0.54 meters or 54 centimeter, that's fine, both fine. But you have to put a unit behind your answer, after your answer, okay? Or else doesn't mean anything. What, 0.54 ducks or 54 chickens? You know, that doesn't work. Alright, okay, let's get into a little commercial break before we come back for question 4.